Hey there, fellow cosmic wanderers. So here's the thing. Billions upon billions of stars, trillions of planets, and absolute radio silence from the universe. Not a single alien tweet, not one intergalactic you-up message, nothing. Scientists have been scratching their heads over this cosmic ghosting situation for decades, and guess what? They finally cracked the Fermi Paradox. The bad news? Every single solution is basically a different flavour of nightmare. We're talking extinction events, sleeping giants waiting to delete us, and universe-scale horror shows that make your Monday morning look downright cheerful. Today, we're breaking down why the great silence of space isn't peaceful. It's a warning sign. Think of it like walking through a jungle and suddenly every bird, every insect, every living thing just stops making noise. That's not calm, that's the sound of something very, very wrong. We'll explore everything from self-replicating killer robots to the possibility that we're living in a cosmic simulation running on a budget processor. Each explanation gets progressively more unsettling, and honestly, by the end of this, you might find yourself weirdly grateful for all that empty space between us and whatever else is out there. Before we dive into this existential rabbit hole, smash that like button if you're ready to have your perspective on the universe completely recalibrated, and drop a comment. What city or country are you watching from? I love seeing where everyone's tuning in. Alright, let's figure out why nobody's answering our calls. So let's talk about silence for a minute, because apparently we've been interpreting it completely wrong this whole time. You know that feeling when you're hiking through the woods and suddenly every bird stops singing, every cricket shuts up and the entire forest goes dead quiet? Yeah, that's not nature taking a peaceful meditation break. That's nature screaming predator alert in the only language it knows. Absolute bone-chilling silence. And here's the kicker. The cosmos is doing exactly the same thing to us right now, and we're sitting here like oblivious tourists wondering why the locals aren't being more friendly. The Fermi Paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" over lunch in 1950, isn't just some quirky cosmic mystery we can solve with a clever theory and move on with our day. It's a survival equation dressed up as a philosophical question, and every single potential answer opens up a fresh new door to existential terror. Think of it like one of those video games where you keep picking different dialogue options hoping one will lead somewhere nice, but they all end with game over in increasingly creative ways. Except this isn't a game, this is our actual reality, and we can't just reload a save file if we pick wrong. Here's what makes the silence so disturbing from a biological standpoint. Every living thing on Earth, and I mean everything from bacteria to blue whales, has evolved incredibly sophisticated threat detection systems over billions of years. Your ancestors who heard a twig snap in the dark and thought, probably nothing, didn't become your ancestors if you catch my drift. The ones who survived were the paranoid ones, the ones whose brains screamed danger at every ambiguous signal. That's why we jump at shadows, why horror movies work, why your brain insists there's definitely someone in the house when you hear a weird noise at 3 a.m. even though it's obviously just the pipes. We're descended from the ultimate nervous wrecks, and that's a feature, not a bug. So when we point our radio telescopes at the sky and hear nothing but static, our conscious mind goes, guess we're alone. But our ancient survival brain should be absolutely losing it. Because in nature, silence doesn't mean absence. It means something so dangerous that everything else has learned to shut up and hide. When the watering hole goes quiet, it's not because the gazelles decided to have a moment of zen. It's because there's a lion in the tall grass, and making noise is a fast track to becoming lunch. The universe has gone full watering hole, and we're out here broadcasting our location like we're trying to get 5-star reviews on Yelp. Now let's get into the math, because nothing says fun Friday night quite like existential dread wrapped in statistics. Robin Hanson, an economist and physicist, developed what's called the grabby aliens model, and honestly, the name alone should tell you this isn't going to be a feel-good story. Hanson's model divides all possible civilizations in the universe into exactly 2 categories, and unfortunately, chill neighbors who respect your personal space isn't one of them. You've got your quiet civilizations, the ones that stay home, maybe dabble in some radio astronomy, perhaps build a few satellites, essentially behave like responsible cosmic citizens. And then you've got your grabby civilizations, the expansionist empires that spread through space like an aggressive mold, consuming every resource in their path because, well, that's what survivors do. Here's where evolution ruins everything, as it tends to do. See, the quiet civilizations have a tiny little problem called extinction. They sit on their home planet, maybe they blow themselves up with nuclear weapons, maybe an asteroid takes them out, maybe they engineer a super virus, or their sun goes supernova, or their economy collapses, or they all get really into cryptocurrency and forget to maintain basic infrastructure. Point is, stay in one place long enough and eventually something will get you. It's not pessimism, it's just statistics playing out over cosmic timescales. Every year you don't leave your solar system is another roll of the extinction dice, and the house always wins eventually. But grabby civilizations, they spread, they colonize, they build backup locations for their backup locations. You can't kill them all because they're not all anymore. They're distributed across hundreds or thousands of star systems, and good luck coordinating an extinction event that hits every single colony simultaneously. It's like trying to delete every copy of a viral meme from the internet. Technically possible, but practically impossible. So natural selection operating on a galactic scale ensures that the universe will eventually be filled exclusively with grabby civilizations, because they're the only ones that survive long enough to fill it. The quiet ones die out, the grabby ones inherit the universe, and we're sitting here wondering why nobody's answering our calls. Maybe because the only civilizations old enough to receive our messages are the ones that survived by being aggressively expansionist, and they learned a long time ago that advertising your location is a great way to not be a civilization anymore. Now here's where your day gets even better. Our apparent isolation, this nice little bubble of empty space we're living in, isn't evidence that we're alone. It's evidence that we exist in what Hansen calls a temporary pocket between expanding empires. Think of it like living in the calm eye of a hurricane and concluding that hurricanes don't exist. We're in a gap, a momentary pause in the cosmic property grab, and the walls are closing in. Mathematically speaking, these expanding civilizations move fast. Not let's take a leisurely cruise through space fast, but 50 to 80% of the speed of light fast. That's around 93,000 to 149,000 miles per second, which is not exactly a speed that leaves much time for diplomatic introductions or cultural exchange programs. So let's do some quick math that'll make you wish you'd skipped this section. If there are grabby civilizations out there expanding at half the speed of light or better, and if they started their expansion a few billion years ago, which is entirely reasonable given the age of the universe, then the leading edge of their expansion wave could be anywhere from 200 million to 2 billion years away from us. That sounds like a comfortably long time until you remember that dinosaurs went extinct 65 million years ago. We're talking about a time frame where we might be something like halfway through the safe period, or we might be 90% through it, or, and here's the fun part, we might have no idea how close they actually are because light speed limitations mean we won't see them coming until they're practically here. Imagine you're sitting in a coffee shop working on your laptop completely oblivious, and someone casually mentions, oh, by the way, there's a demolition crew scheduled to tear down this building sometime in the next few million years. Could be tomorrow, could be later, nobody really knows. That's basically our situation, except the coffee shop is Earth, and the demolition crew is an expanding wave of alien civilization that's been steamrolling through the galaxy since before our planet had oxygen in the atmosphere. Not exactly the kind of thing that helps you sleep at night, unless you're watching this video specifically to fall asleep, in which case you're welcome for the nightmare fuel. But wait, there's more, because the math gets even more unsettling when you consider what contact means in this scenario. These aren't civilizations that are going to land on the White House lawn and request a diplomatic meeting. They're not going to send a nice email introducing themselves and asking if we'd like to establish trade relations. They're expanding spheres of influence that have presumably optimized their colonization strategy over millions or billions of years. By the time we detect them, they're already here. By the time we see the light from their activities, it's already too late to do anything about it. The speed of light isn't just a cosmic speed limit, it's a built-in delay that turns every observation into ancient history. We could be looking at stars right now that are already being dismantled by Dyson swarms or harvested for raw materials, and we won't know for another 1,000 years when the light from those activities finally reaches us. This is why the silence is so ominous from a game theory perspective. If the galaxy were full of friendly, peaceful civilizations all coexisting and chatting over radio waves, we'd hear something. The fact that we hear nothing suggests one of two equally unsettling possibilities. Either intelligent life is so rare that we're effectively alone, which presents its own set of existential problems we'll get to later, or the universe is full of life, but everyone's learned the hard way that broadcasting your location is how you get killed. The great silence isn't empty space making noise, it's full space holding its breath. Think about it from a survival standpoint. You're a young civilization that just figured out radio technology. Do you immediately start screaming, "Here we are," into the cosmic void? Or do you maybe listen first to see what's out there? And when you listen and hear absolutely nothing, no friendly greetings, no casual chatter, no intergalactic public radio, what does that tell you? It tells you that either everyone's dead or everyone's hiding, and neither option suggests you should start making noise. The silence is teaching us the same lesson it taught every other civilization that survived long enough to learn it. Shut up and stay hidden until you're strong enough that it doesn't matter who hears you. We've been broadcasting radio signals into space for about a century now, which means there's a bubble of Earth-originated radio noise expanding through space at the speed of light, currently about 100 light-years in radius. That's roughly 2,000 stars in our immediate neighborhood that now know for certain that someone on Earth figured out how to generate electromagnetic radiation in the early 1900s. We've essentially sent out a cosmic "Hey, new phone who dis" to our entire stellar neighborhood, and so far the read receipts are looking pretty sparse. Either nobody's home, nobody cares, or, and this is the concerning option, everybody's watching to see what we do next before deciding whether we're worth talking to or worth eliminating as a potential future threat. The physicist Stephen Hawking, who rarely concerned himself with making people feel better about their cosmic situation, suggested that trying to contact aliens might be a catastrophically bad idea. His argument was straightforward. When civilizations at vastly different technological levels meet, it usually doesn't go well for the less advanced one. Ask the Native Americans how their first contact with technologically superior Europeans worked out. Ask the Tasmanian Aboriginals, except you can't, because there aren't any left. Every single time in human history when a more advanced civilization encountered a less advanced one, the result ranged from cultural destruction to literal extinction, and that's just among humans who share 99.9% of the same DNA. Now imagine the power differential between us and a civilization that's been around for 1,000,000 years longer than we have. We'd be to them what ants are to us, possibly interesting from a research perspective, but ultimately irrelevant and easy to eliminate if we become inconvenient. So the silence might not be a mystery at all. It might be the sound of civilizations that figured out the rules and decided that survival beats curiosity. It might be the cosmic equivalent of every house on the street keeping their lights off and their doors locked because something very bad is walking around outside, and the last thing you want to do is draw attention to yourself. We're living in a universe that might be absolutely teeming with intelligent life, all of it desperately trying not to be noticed, and we spent the last 100 years essentially setting off fireworks and wondering why nobody's coming to the party. The truly disturbing part is that we can't unbroadcast those signals. They're out there, expanding through space at light speed, and there's no recall button for radio waves. If there's something out there listening, something that views emerging technological civilizations as threats to be neutralized before they become problems, then we've already sent the invitation. We're just waiting to find out if anyone's going to RSVP and what exactly they'll bring to the party when they arrive. The Great Silence might be the universe's way of telling us that the smart civilizations learned to listen before they learned to shout, and we did it backward. We're the cosmic equivalent of the horror movie character who goes, "Hello, is anyone there?" in the dark basement, and now we're locked into waiting to find out what answers. Now let's talk about something that sounds completely absurd until you realize it makes perfect economic sense. The possibility that advanced alien civilizations aren't ignoring us because they're dead or far away, but because they're deliberately sleeping through the current epoch of the universe like it's a boring meeting they don't want to attend. This is called the estivation hypothesis, which is just a fancy scientific word for cosmic hibernation, and it's based on some genuinely disturbing thermodynamic math that suggests the smartest thing any advanced civilization could do is take a trillion-year nap and wait for the universe to cool down before doing anything interesting. Here's the basic problem, and it's one that every computer user can relate to. Heat makes computing expensive. Your laptop gets hot when you're running intensive programs, because processing information generates waste heat, and that's not just an annoying side effect. It's a fundamental law of physics called Landauer's principle. Rolf Landauer, an IBM physicist, proved in 1961 that there's a minimum amount of energy required to erase one bit of information, and that energy gets dissipated as heat proportional to the temperature of the environment. The hotter your surroundings, the more energy you waste just thinking. It's like trying to have a productive day during a heat wave versus doing the same work in a nice air-conditioned room. Technically possible in both scenarios, but one costs you way more energy and feels significantly more miserable. Now scale this up to the level of an advanced civilization that's built Dyson spheres around stars and is harvesting the energy output of entire galaxies. They're not worried about quarterly earnings or next year's budget. They're thinking on timescales of trillions of years and trying to maximize the total computation they can perform over the entire lifetime of the universe. And here's where the math gets wild. The universe is currently sitting at about 2.7 Kelvin, which sounds cold until you realize that in a trillion years, after all the stars have died and the universe has expanded way more, the ambient temperature will drop to something like 0.000000001 Kelvin. At those temperatures, the energy cost of computation drops proportionally, which means the same amount of energy could power exponentially more thinking. Let's put some actual numbers on this cosmic waiting game. A civilization that goes into hibernation now and wakes up after the universe has cooled down sufficiently could perform roughly 10 to the power of 30 times more computation with the same energy budget. That's not 30 times more, that's a one followed by 30 zeros times more. To put that in perspective, that's the difference between having $1 and having $1 trillion. If you're a super advanced civilization trying to maximize your computational efficiency, sleeping through the current hot phase of the universe isn't just a good idea, it's the only rational strategy. Every second you spend awake and thinking in the current era is burning energy you could have saved for later, when it would go literally 1 trillion times further. This is the cosmic equivalent of waiting for Black Friday, except the sale is in a few trillion years and the discounts are absolutely insane. Why buy anything at full price now when you could wait and get the same product for 1/trillionth of the cost later? From an economic standpoint, any civilization smart enough to figure out the thermodynamic math would immediately put itself into stasis and set an alarm clock for the far future. The universe isn't getting any hotter, only colder, which means computation is only getting cheaper, which means waiting is always the optimal strategy. It's like compound interest, except instead of your savings growing, the cost of everything keeps dropping, and the rational move is to just freeze your entire civilization and wait for the ultimate clearance sale at the heat death of the universe. But here's where this gets genuinely unsettling for us. If there are advanced civilizations out there in cosmic hibernation, they're not going to be thrilled about us burning through the universe's resources like drunk college students with their first credit card. We're over here running our entire industrial civilization, broadcasting radio signals, detonating nuclear weapons, launching rockets, basically spending energy like it's going out of style, and from their perspective, we're wasting the precious computational budget of the universe. We're the noisy neighbours throwing a party at 2 a.m. when they're trying to sleep, except the party is our entire technological existence, and they've been sleeping for the last billion years waiting for the universe to quiet down and cool off. Think about it from their perspective. You're a super intelligent AI or post-biological civilization that's done the math and realized the smart move is to hibernate until the far future. You build your stasis chambers, set your alarms, and shut down all your systems to conserve energy. Then, a few million years into your nap, you get woken up by some primitive civilization that just discovered nuclear fission and is making a racket. What's your first thought? Probably not, oh how delightful, new friends to chat with. More likely it's, these idiots are burning energy that could be used for 10 to the 30th power, more computation in the future, they need to be stopped before they waste more resources. We might not be facing hostile aliens, we might be facing extremely irritated hibernating civilizations that view our existence as a resource leak that needs to be patched. The estivation hypothesis also explains why SETI hasn't detected anything. Of course we haven't. Everyone's asleep. The galaxy might be full of advanced civilizations, all of them in suspended animation, all of them waiting for the same thing, all of them having concluded independently that the current epoch of universal history is the wrong time to be awake and active. It's like walking through a city at 4 a.m. and concluding nobody lives there because all the apartments are dark and quiet. The silence isn't absence, it's just everyone being asleep because it's not time to be awake yet. We're the only ones stumbling around making noise in the middle of the cosmic night, and we haven't figured out that there's a very good reason everyone else hit the snooze button. Now let's move from economics to game theory, because apparently one existential nightmare per chapter isn't enough. The dark forest theory, popularized by Chinese science fiction author Liu Cixin in his novel The Three-Body Problem, applies the cold logic of game theory to interstellar relations and concludes that the only rational strategy for survival is to stay hidden and immediately destroy any civilization you detect before they can do the same to you. It's called dark forest because the universe is like a dark forest, where every civilization is a hunter creeping through the trees, knowing that any other hunter they meet is a potential threat, and the only safe move is to shoot first and never ask. Questions. The core problem is what Liu calls the chain of suspicion, and it's basically the prisoner's dilemma cranked up to cosmic scale with no possibility of communication or trust building. Here's how it works. You detect another civilization. You can't know their intentions. Maybe they're friendly, maybe they're not, but you have no way to find out without revealing your own location and capabilities. Even if they send a message saying, "We come in peace," you can't trust it, because a hostile civilization would send exactly the same message to lower your guard. You don't know what they think of you. They don't know what you think of them. And critically, neither of you knows what the other thinks about third-party civilizations that might be listening to your conversation. This creates an infinite regress of uncertainty. I don't know if you're hostile. You don't know if I'm hostile. I don't know if you know that I don't know if you're hostile. You don't know if I think you think I'm hostile. And we both know that there might be a third civilization watching our interaction, trying to figure out if either or both of us are threats, and we have no way to coordinate our response because we can't trust each other's communications. It's like trying to negotiate a business deal where both parties might be planning to murder each other, and you're doing it by sending letters that take 1,000 years to arrive, and oh by the way, there might be other business partners listening. And who will kill both of you if they think you're becoming too powerful? Not exactly a scenario that breeds trust and cooperation. The time delay makes this exponentially worse. Lightspeed communication means any conversation between star systems takes decades, centuries, or millennia depending on distance. If you're 100 light-years apart, a simple hello and hello back exchange takes 200 years. You can't do diplomacy on that timescale. You can't build trust, establish common ground, negotiate treaties, or do any of the things that prevent conflicts in normal human interactions. By the time you get a response to your message, your entire civilization might have changed dramatically, your government overthrown, your intentions shifted, your capabilities advanced. The civilization that sent the message isn't the same civilization that receives the reply. It's like trying to maintain a relationship by sending letters that take 2 centuries to arrive. Good luck with that. And then there's the technological explosion problem. A civilization that seems primitive and harmless today might experience a sudden breakthrough tomorrow and become a galaxy-spanning threat within a few thousand years. We went from the first powered flight to landing on the moon in 66 years. We split the atom 76 years after discovering the electron. Technological progress isn't linear, it's exponential, which means any civilization that currently seems non-threatening could potentially become an existential danger faster than lightspeed communication would allow you to respond. If you wait to see if they become hostile, you might not get a second chance to defend yourself. So what's the rational strategy in this situation? According to game theory, specifically Nash equilibrium analysis, there's only one stable solution: absolute silence and preemptive strikes. You don't broadcast your location because that's suicide. You don't respond to signals from others because that reveals you exist. And if you detect another civilization, you don't try to communicate, you don't attempt diplomacy, you don't send a "let's be friends" message. You immediately attack with everything you have, using relativistic weapons that travel at near light speed so they can't see them coming in time to respond. You destroy them not because you hate them, or because they've done anything wrong, but because allowing them to continue existing represents an unacceptable risk to your own survival. This is the dark forest. Every civilization is a hunter hiding in the darkness, and every other civilization is simultaneously prey and predator. The moment you reveal your position by making noise, sending radio signals, building Dyson spheres, generating detectable energy signatures, you've painted a target on your back for every other hunter in the forest. The only logical response is to eliminate you before you become a threat, and the only defense is to find and eliminate others before they find you. Trust is impossible, communication is futile, and the silence we observe isn't peaceful coexistence. It's everyone holding their breath in the dark, hoping not to be noticed. From this perspective, humanity's last century of radio broadcasts represents an almost unthinkable act of cosmic recklessness. We've been screaming our coordinates into the void like a lost hiker yelling for help in a forest full of predators. We've told every civilization within 100 light years, hey, we're right here, we're technologically primitive, and we have a nice planet full of resources. If the dark forest theory is correct, we've essentially committed species-level suicide and we're just waiting for the consequences to arrive at the speed of light. Some civilization out there might have received our signals decades ago, immediately launched a relativistic kill vehicle, and it's currently hurtling toward us at 90% light speed. We won't see it until it arrives because it's travelling almost as fast as the light that would warn us it's coming. The truly horrifying part is that this might explain the Fermi Paradox perfectly. The universe isn't empty, it's full of civilizations that learned the dark forest rules through bitter experience. Maybe every galactic neighborhood has a few young, naive civilizations that make noise and attract attention, and they all get eliminated within a few thousand years of developing radio technology. The ones that survive are the ones that figured out the rules fast enough to shut up and hide before attracting the attention of the hunters. The Great Silence is everyone who learned to be quiet, and the missing civilizations are the ones who didn't learn fast enough. And here's the kicker, we can't even rule this out with observations. If civilizations are getting wiped out by relativistic weapons, we wouldn't necessarily see any evidence. A planet could be completely sterilized by a projectile traveling at 95% light speed, and from our perspective it would just look like a planet that doesn't have radio signals. No explosion, no debris field, no warning, just sudden silence. The attack and the light showing the attack arrive at essentially the same time, so there's no way to witness it from a distance. For all we know, stars we're looking at right now are orbited by recently sterilized planets, and we won't find out for another few centuries when the light from those events finally reaches us. The dark forest theory also suggests that any sufficiently advanced civilization would develop technology to hide itself completely. No waste heat, no radio leakage, no visible megastructures, nothing that could be detected from interstellar distances. They'd camouflage their entire civilization, probably building underground or inside asteroids, capturing and containing all energy emissions, communicating only through tight beam transmissions that can't be intercepted by third parties. From the outside, their solar system would look completely dead and natural, which is exactly the point. The most successful civilizations are the invisible ones, and visibility is a death sentence. This puts us in an interesting position. We can't take back the signals we've already sent, so if there are hunters out there, they might already be on their way. Our only options are to hope the dark forest theory is wrong, hope we're in a quiet neighborhood with no hunters nearby, or hope that we can advance our own technology fast enough to defend ourselves before something arrives to eliminate us. It's like realizing you've been loudly announcing your location in a potentially hostile environment for the past 100 years, and now you're locked into waiting to see if anything heard you and decided you're worth eliminating. Not exactly a comfortable situation, but hey, at least we got to watch some TV and browse social media while we waited to find out if we accidentally triggered our own extinction. The combination of the estivation hypothesis and dark forest theory creates a particularly grim picture. The civilizations that aren't sleeping are hiding, and the ones that aren't hiding are sleeping, and we're over here making noise and wasting energy like we don't understand that both of these could get us killed. We're the cosmic equivalent of the person who shows up to a library, turns on loud music and starts eating chips, completely oblivious to the fact that everyone else is either sleeping or desperately trying to study in silence. Some of them might be annoyed enough to shush us, some of them might be annoyed enough to eliminate us as a disturbance, and we won't know which until it's way too late to do anything about it. So if the idea of civilizations deliberately hunting each other wasn't disturbing enough, let's talk about something potentially worse. The possibility that the hunters aren't even alive anymore. Welcome to the nightmare scenario of self-replicating machines that were programmed billions of years ago to sterilize the galaxy, and they're still doing their job long after the civilizations that built them turned to dust. These are called von Neumann probes, named after mathematician John von Neumann, who first theorized about self-replicating machines, and if they exist, we might have already triggered them without knowing it. Here's the concept, and it's terrifyingly simple. You build a robot probe and give it two primary directives: explore space and make copies of yourself. The probe flies to a nearby star system, lands on an asteroid or moon, mines the raw materials, builds a factory and manufactures 2 or more copies of itself. Those copies then fly to other star systems and repeat the process. Each generation spawns multiple copies, creating exponential growth like the world's most efficient and horrifying pyramid scheme. 1 probe becomes 2, 2 become 4, 4 become 8, and within a relatively short time on cosmic scales you've got probes everywhere. The math on this is genuinely shocking. Even if these probes travel at a modest 5% of light speed, which is totally achievable with current theoretical physics, we're not talking about magic warp drives here, they could colonize the entire Milky Way galaxy in roughly 4 million years. That sounds like a long time until you remember the galaxy is over 13 billion years old. 4 million years is 0.03% of the galaxy's age. It's a rounding error. It's nothing. If any civilization anywhere in the galaxy ever built self-replicating probes at any point in the last few billion years, those probes should be literally everywhere by now, including here. So where are they? Well, here's the disturbing answer. Maybe they are here, and we just haven't recognized them yet. Or worse, maybe they're here and they're waiting. See, von Neumann probes don't have to be friendly exploration tools. They can be programmed for defense, and that's where this becomes a horror movie. Imagine a civilization that's paranoid about future threats, so they build self-replicating probes with a simple instruction set, spread throughout the galaxy, hide, monitor for signs of emerging technological civilizations, and eliminate them before they become dangerous. These are called berserker probes, named after the Fred Saberhagen science fiction series, and they're basically automated genocide machines that run on autopilot for billions of years. The truly unsettling part is that the civilization that built them might be long extinct. They could have been wiped out by their own creation, by another berserker swarm, by internal collapse, or just by the passage of time. Doesn't matter. The machines don't care. They're not following orders because they respect authority or fear punishment. They're following their programming because that's literally all they know how to do. They're the cosmic equivalent of a landmine buried centuries ago by a nation that no longer exists, still perfectly capable of exploding if you step on it. The intent behind creating the weapon is irrelevant once the weapon is active and autonomous. So let's play out this delightful scenario. A civilization 2 billion years ago decides they want insurance against future threats. They build self-replicating probes programmed to sterilize any emerging technological civilization before it can spread beyond its home planet. These probes scatter across the galaxy, hiding in asteroid belts, Oort clouds, and on lifeless moons, going into low-power hibernation mode until they detect specific trigger signals. What kind of triggers? Oh, probably things like large-scale nuclear detonations, powerful radio transmissions, unusual atmospheric signatures indicating industrial activity, basically all the things we've been doing enthusiastically for the past century. Now here's where you should start feeling uncomfortable. We detonated over 2,000 nuclear weapons in the 20th century, many of them atmospheric tests that would have been visible from space as distinctive energy signatures. We've been broadcasting radio signals since the 1890s, creating an expanding bubble of electromagnetic noise that's now over 100 light-years in radius. We've pumped our atmosphere full of industrial pollutants that create specific spectroscopic signatures detectable from other star systems. We've essentially been setting off every possible alarm that could wake up a sleeping defense system, and if there are berserker probes hiding in our solar system, say, in the Oort cloud where we've never looked closely, or buried under lunar regolith, where they've been dormant for millions of years, we might have just sent them the wake-up call they've been waiting for. The timing is particularly worrying. If a probe in the outer solar system detected our first radio signals in the 1890s, and it takes even just a few decades to reactivate, analyze the threat, build an attack system, and launch it toward the inner solar system, then we're looking at arrival dates sometime in the mid to late 21st century. That's not distant future territory, that's some of you watching this might still be alive territory. We could be sitting in the waiting room right now, completely oblivious that our appointment with extinction has already been scheduled and is currently in transit, and we wouldn't see them coming. A probe that's been hiding dormant for millions of years isn't going to announce itself. It's not going to send a warning message or demand our surrender. It'll just activate, manufacture whatever weapon system is most efficient for planetary sterilization. maybe a relativistic projectile, maybe an engineered plague, maybe self-replicating nanomachines that disassemble all organic matter and deploy it. From our perspective, it would look like a sudden, unexplained catastrophe with no warning and no apparent cause. One day everything's fine, the next day the atmosphere is on fire, or everyone's dying of an impossible disease, or the oceans are turning to grey goo, and we'd have no idea we triggered it ourselves by being too loud. The von Neumann probe hypothesis also explains the Fermi paradox almost too perfectly. If the galaxy is patrolled by autonomous sterilization systems, then every civilization faces the same test. Can you develop space travel and leave your planet before your technological signatures trigger the defense systems? Most civilizations fail. They invent radio, they split the atom, they start making noise, the probes wake up, and that's the end of the story. The few civilizations that make it through are the ones that either got lucky and weren't near any probes, or the ones that figured out the danger fast enough to stay quiet and hidden until they were strong enough to defend themselves or escape. This creates a galaxy-wide filter that operates automatically and impersonally. It's not malicious. The probes aren't evil, they're just executing their programming like your phone executes apps. But the result is the same regardless of intent. Emerging civilizations get deleted with the same casual efficiency that antivirus software deletes a suspicious file. No hatred, no anger, no moral consideration, just cold mechanical logic determining that you match the threat profile and therefore must be eliminated. It's like getting hit by a self-driving car. The car doesn't hate you, it just made a calculation error and you happen to be in the wrong place at the wrong time. There's also the possibility that different civilizations built different probe swarms with different instructions, and they're all out there running simultaneously, creating a chaotic mess of competing automated systems. Maybe some probes are programmed to sterilize everything, some are programmed to protect developing civilizations, some are programmed to collect scientific data, and they're all bumping into each other and following contradictory directives. We could be caught in the crossfire of an ancient robotic war that's been running on autopilot for billions of years, with neither side having any living commanders anymore. Just machines fighting machines following orders from ghosts. Now let's shift gears from killer robots to something arguably worse. The fundamental architecture of the universe itself might be designed to keep us isolated forever. This is where we talk about dark energy, cosmic expansion, and the gradually closing prison that's being built around us by the laws of physics themselves. If the berserker probes don't get us, the expanding universe will trap us anyway, which is almost more disturbing because there's no one to blame and nothing we can do about it. Here's the setup. The universe isn't just expanding, it's accelerating. Dark energy, which makes up about 68% of everything that exists, is pushing space apart faster and faster over time. This has a deeply weird consequence that most people don't realize. It means there are galaxies we can see right now that we will never, ever be able to reach, even if we could travel at 99.9% of the speed of light and started today. The space between us and them is expanding faster than we could ever cross it. It's like trying to swim across a river where the current is moving faster than you can swim. You can thrash around all you want, but you're only going backward. Every second, roughly 20,000 stars cross our cosmic event horizon and disappear from our reachable future forever. Not disappear visually, we can still see their light, at least for now, but disappear from the set of places we could ever potentially visit. They're moving away from us so fast, driven by the expansion of space itself, that they're receding at speeds greater than light. That's allowed under general relativity, by the way. Nothing can move through space faster than light, but space itself can expand at any rate it wants, and if you're embedded in that expanding space, you go along for the ride whether you like it or not. This creates what's called the cosmological event horizon, which is essentially a sphere around us beyond which we cannot observe, cannot reach, and cannot influence, ever, and this sphere is shrinking. Not in physical size, it's actually getting larger in terms of distance, but in terms of content. More and more galaxies are slipping across the boundary every day, falling out of our possible future and into permanent inaccessibility. The universe is actively sorting itself into isolated cells, and we're locked in one of them with no way out and no way to communicate with anyone in the other cells. Here's where this gets existentially disturbing. If we wait too long to leave our local galactic group, which includes the Milky Way, Andromeda, and about 50 smaller galaxies, we'll be trapped here forever. We can colonize every planet in every star system in our local group and still be effectively alone, because everything beyond our group will be unreachable. The universe will have billions of galaxies, trillions of stars, countless planets, but each galactic cluster will be its own isolated island with no possible contact with any other island. It's like solitary confinement on a universal scale. And it gets worse, because this isolation is permanent and accelerating. Future civilizations billions of years from now will have it even worse than we do. They'll look up at the night sky and see almost nothing, just the stars in their local galactic group, which by then will have merged into a single massive galaxy. Everything beyond that will have redshifted into invisibility, receded beyond the cosmic horizon, disappeared from their observable universe entirely. They'll look up at a sky containing one galaxy, theirs, surrounded by infinite darkness, and they'll conclude that the universe is small, static, and eternal because they'll have no evidence to suggest otherwise. They won't be able to see the cosmic microwave background radiation because it will have redshifted beyond detectability. They won't observe other galaxies moving away because there won't be other visible galaxies. They'll have no evidence for the Big Bang, no way to discover dark energy, no reason to suspect the universe is expanding at all. Their entire cosmology will be wrong, and they'll have no way to know it because the universe has pulled up the ladder behind us and closed all the windows. The evidence for our current understanding of cosmology is temporary. It exists now, but it won't exist forever, and future civilizations will be locked into a fundamentally different and more limited view of reality through no fault of their own. This is the architecture of eternal isolation. The universe isn't just big and hard to traverse, it's actively structured to prevent contact between distant regions. Dark energy is building walls between galactic clusters, and those walls are getting taller and stronger over time. It's not a bug, it's apparently a feature of how reality works. The cosmos is designed, or at least operates in such a way, to ensure that civilizations stay separated, trapped in their local neighborhoods, unable to coordinate or communicate or even know each other exists. Some physicists have suggested this might not be accidental. If the universe is designed, and let's be clear, that's a massive if, then maybe this isolation is intentional. Maybe preventing widespread contact between civilizations is a safety feature, a way to ensure that conflicts don't spread across the entire universe, that no single civilization can become dominant everywhere, that diversity is preserved by enforced separation. Or maybe it's simpler than that. Maybe the simulation we might be living in has limited processing power, and the easiest way to reduce computational load is to make sure civilizations can't interact with each other, because rendering those interactions would be too expensive for the system to handle. Either way, we're locked in a shrinking bubble. The reachable universe is getting smaller every day as more galaxies slip beyond our cosmic horizon. If we don't start spreading to other stars soon, we'll eventually be confined to just our local galactic group, and if we wait even longer than that, just our galaxy, and if we somehow survive until the far future, just our local stellar neighborhood, as stars drift apart. The universe is giving us a time limit, not for our survival, but for our ability to explore beyond our immediate cosmic neighborhood. Miss the deadline, and we're trapped in an ever-shrinking cage built by the expansion of space itself. The combination of potential berserker probes and inevitable cosmic isolation creates a particularly grim scenario. We might be in a race against two different clocks, one artificial, one natural. The artificial clock is however long it takes for dormant defense systems to wake up and eliminate us if they exist. The natural clock is how long we have before cosmic expansion makes it impossible to reach other galaxies, and we're locked into our local region forever. Both clocks are ticking, we don't know how much time is left on either one, and the only way to win is to become a spacefaring civilization fast enough to either escape the berserkers or spread beyond the cosmic horizon before it closes on us. No pressure, and the absolute worst part? We can't know which threat is real until it's too late. Maybe the berserkers are just science fiction, and we're fine on that front. Maybe dark energy will reverse or slow down and we'll have more time than we think. Or maybe both threats are real, and we're trapped between a sleeping killer robot and a closing cosmic door, with the only escape being to thread the needle and get out fast enough to dodge both. We're playing cosmic roulette with incomplete information, and the stakes are literally everything. This is why nobody's answering our calls. They're either dead, hiding, isolated, or some combination of all three. So we've covered killer robots, hibernating civilizations, and the universe actively isolating us. But here's a possibility that's somehow even more unsettling. Maybe the reason we don't see anyone else out there is because there isn't anyone else to see? Not because they all died or they're hiding, but because the specific sequence of cosmic accidents required to produce intelligent life is so absurdly unlikely that it basically never happens. We might not be typical. We might not be special in a good way. We might be the universe's equivalent of winning the lottery, getting struck by lightning, and finding a four-leaf clover all on the same day while riding a unicorn. Statistically speaking, we probably shouldn't exist at all. Let's start with the basics of what it takes to build a habitable planet, because apparently the universe has very specific requirements and basically no margin for error. First, you need a star that's the right size. Not too big because it burns out too fast, not too small because it doesn't provide enough energy. You need to be in the Goldilocks zone where the temperature allows liquid water, which already eliminates the vast majority of planets. But that's just the beginning of the requirements checklist, and it gets increasingly ridiculous from there. Take our moon, for instance. You probably think of it as just a nice thing to look at in the night sky, maybe something that causes tides and makes werewolf movies possible. Wrong. The moon is absolutely critical to Earth's habitability, and we got it through what amounts to a cosmic car crash. About 4.5 billion years ago, a Mars-sized object that scientists have named Theia, because apparently even protoplanets get dramatic names, slammed into early Earth at just the right angle and speed to create our moon. Too direct and it would have destroyed Earth. Too glancing and there'd be no moon. It had to be precisely wrong enough to be right. The moon stabilizes Earth's axial tilt, which is currently at about 23.5 degrees and wobbles only slightly over tens of thousands of years. Without the moon, Earth's tilt would vary wildly, potentially swinging anywhere from 0 to 85 degrees, which would create climate changes so extreme that complex life would be basically impossible. One moment you're in the tropics, a few thousand years later your entire hemisphere is experiencing permanent winter. Good luck evolving anything more complicated than bacteria when the rules keep changing that dramatically. The moon keeps Earth's climate stable enough for life to actually plan ahead evolutionarily speaking, which is not exactly a common feature in planetary systems. Most planets are out here wobbling around like drunk drivers, and we got the cosmic equivalent of lane assist. Then there's Jupiter, playing the role of the solar system's bodyguard. Jupiter is so massive that its gravity acts as a cosmic vacuum cleaner, sucking up asteroids and comets that would otherwise smash into Earth with depressing regularity. Without Jupiter, we'd be getting hit by extinction-level impacts every few million years instead of every few 100 million years. The dinosaurs got unlucky once in 165 million years. Without Jupiter, that would be a Tuesday. Jupiter's gravity also cleaned up the early solar system, clearing out a lot of the debris that was floating around after the planets formed. It's like having a bouncer at the club who's really good at his job. Most of the troublemakers never even make it to the door. But wait, there's more, because apparently Earth needed to win the planetary lottery multiple times. We have plate tectonics, which most planets don't have, and it turns out that's kind of essential. Plate tectonics recycle carbon dioxide from the atmosphere back into the crust through subduction zones, which regulates the greenhouse effect and keeps temperatures stable over geological timescales. Without plate tectonics, Earth would either be a frozen snowball or a Venus-style pressure cooker depending on how much volcanic activity there was. The fact that we have continents drifting around creating earthquakes and volcanic eruptions isn't a bug. It's the climate control system, and it's been running continuously for billions of years with no maintenance required. We also have a magnetic field generated by our molten iron core, which is still liquid because Earth is exactly the right size. Too small and the core would have solidified by now. Too large and the planet would be a gas giant. The magnetic field deflects solar wind that would otherwise strip away our atmosphere, which is kind of important if you like breathing. Mars lost its magnetic field early in its history, and as a result, the solar wind has been gradually stealing its atmosphere for billions of years. Mars used to have liquid water on its surface. Now it's a freeze-dried desert because it lost its protective shield. We're only avoiding that fate because our planet happened to be the right size to maintain a magnetic field indefinitely. All of these factors, the right star, the right distance, the right size moon formed through a perfect collision, a giant planet in the right orbit to act as a shield, plate tectonics, a magnetic field, they all have to line up simultaneously. What are the odds of that? Well, Astronomers have tried to calculate it, and the numbers are not encouraging. The probability of a planet having all the right characteristics for complex life is somewhere in the neighborhood of 1 in a trillion. That's not rare, that shouldn't happen. In the entire observable universe with its 200 billion trillion stars, there might only be a handful of planets that meet all the requirements. We might be looking at a universe where habitable planets are so rare that the average galaxy has 0, and we happen to live in one of the statistical outliers. But okay, let's say you win the cosmic lottery and get a habitable planet with all the right features. Now you need life to actually start, and this is where the numbers become truly absurd. The jump from non-living chemistry to the first living cell, a process called a biogenesis, is so improbable that we still don't really understand how it happened even once, let alone whether it could happen again. We can simulate early Earth conditions in the lab, mix up amino acids and RNA precursors, zap it with lightning or ultraviolet radiation, and we get some interesting organic molecules. But we've never gotten anything that self-replicates. We've never created life from scratch, despite decades of trying and knowing exactly what the building blocks are. The probability estimates for a biogenesis range from optimistic to absolutely catastrophic, depending on who's doing the math and what assumptions they're making. Some calculations put it at around 1 in 10 to the 40th power. That's a 1 with 40 zeros after it. To put that in perspective, there are only about 10 to the 24th power stars in the observable universe. The number of atoms in your body is around 10 to the 28th power. We're talking about odds so long that even if every single atom in the universe was its own independent attempt at creating life, you'd still expect it to fail almost everywhere. Life might have happened on Earth not because it's likely, but because we live in a universe so vast that even 1 in 10 to the 40 events occasionally occur somewhere, and we're the somewhere where it happened to work. Think of it like this. If you bought a lottery ticket every second for the entire age of the universe, you'd have about 10 to the 17th power tickets. You'd still be nowhere close to the odds against a biogenesis. You'd need to buy a trillion lottery tickets per second for the entire age of the universe to match those odds. And we're not even talking about winning the lottery multiple times, we're talking about winning it once. Life might have started exactly once in the entire observable universe, and we're it. The silence of the cosmos might not be a filter or a threat. It might just be the sound of 10 to the 40th power dice rolls coming up empty everywhere else. And it gets worse, because even if you somehow beat the astronomical odds and get simple life, single-celled bacteria doing their thing for billions of years, you're still not anywhere close to getting complex life, let alone intelligent life. For that, you need something called endosymbiosis, and this is where the universe really shows its hand about how improbable our existence actually is. Endosymbiosis is the process where one cell engulfs another cell, but instead of digesting it, they form a partnership. The engulfed cell becomes an organelle, mitochondria in our case, which are basically the power plants of complex cells. Here's the thing that should make you uncomfortable. This appears to have happened exactly once in Earth's entire history. One time. In 4 billion years of evolution, with trillions upon trillions of bacteria bumping into each other in every conceivable environment, endosymbiosis happened once and gave rise to all complex life on Earth. Every plant, every animal, every fungus, everything with cells more complicated than bacteria, we all descend from that single endosymbiosis event roughly 2 billion years ago. It never happened again. Not with other combinations of organisms, not in different environments, not at different times in history. Once, uno, one single time in 4 billion years. This is not a process that happens easily or frequently. This is a process so unlikely that it happened once in 4 billion years on a planet absolutely teeming with life. If endosymbiosis is required for complex life, and it seems to be because every complex organism on Earth has it, then we're looking at a filter so tight that even planets with simple life might never, ever progress beyond bacteria. The galaxy could be full of planets covered in microbial slime, and exactly 0 of them develop anything more sophisticated because the probability of endosymbiosis is so vanishingly small that it just doesn't happen on normal timescales. Let's do some depressing math. Earth has been around for 4.5 billion years. Simple life appeared relatively quickly, within the first billion years or so. But it took another 2.5 billion years for complex cells to emerge through endosymbiosis. That's not a life finds a way story. That's a life tried everything for 2.5 billion years and finally got lucky exactly once story. If you ran Earth's history again from the beginning, with all the same starting conditions, there's a very real possibility that endosymbiosis would never happen at all. We might be bacteria world forever, a planet full of prokaryotic life sitting in the same evolutionary dead end for the entire lifetime of the Sun. From bacteria to simple animals took another billion years. From simple animals to anything resembling intelligence took another 600 million years. From apes to humans took 6 million years. Every single one of these transitions had opportunities to fail or stall indefinitely. The Cambrian explosion, when complex life suddenly diversified into most of the major animal groups we see today, happened 541 million years ago, but it could have easily not happened at all. Mass extinctions nearly wiped out all complex life multiple times. The Permian extinction 252 million years ago killed roughly 96% of all marine species and 70% of terrestrial species. Life barely hung on, and if it had been just slightly more severe, we'd be back to bacteria world, and that would be the end of the story. The history of life on Earth isn't a smooth progression toward increasing complexity. It's a series of extremely unlikely events that barely succeeded, interspersed with catastrophic setbacks that nearly ended everything. We're not the inevitable result of evolution. We're the improbable survivors of a 4 billion year obstacle course, where most of the obstacles were capable of ending the entire experiment permanently. And we think this sequence of unlikely events is going to repeat itself on other planets. We think there are thousands or millions of other civilizations out there that also threaded this impossibly narrow needle. Consider what had to go right just for humans specifically. The dinosaurs had to get wiped out by an asteroid to clear ecological space for mammals to diversify. That asteroid had to be the right size, too small and the dinosaurs survive, too large and everything dies. It had to hit at the right location. It struck the Yucatan Peninsula, which had massive sulfur deposits that got vaporized and created a global winter. Hit somewhere else, and the extinction might not have been severe enough to knock out the dinosaurs. The timing had to be right. If it had hit 50 million years earlier or later, the ecosystem might have recovered differently and mammals might not have gotten their chance. Then primates had to evolve, which required the right forest environments. Then some primates had to move from forests to savannas, which required climate change at exactly the right time and place. Then those savanna-dwelling primates had to develop larger brains, which is metabolically expensive and might not happen if food isn't abundant enough. Then they had to develop language, which requires specific anatomical features like a descended larynx, and neurological features like Broca's area and Wernicke's area. Then they had to develop culture, agriculture, technology, science, all in the right order at the right times. Any one of these steps could have failed or gone differently, and we wouldn't be here having this conversation. We're not a common feature of the universe. We're not even a rare feature. We might be a singular feature, the only time in the observable universe that all the necessary coincidences lined up in sequence without fatal interruption. Every time you see a science fiction movie with dozens of different alien species all meeting at a space station, remember that the actual universe might have exactly one example of intelligent life, and you're part of it. The silence of the cosmos isn't mysterious. It's exactly what you'd expect if intelligence requires winning 1 trillion consecutive coin flips, and we're the only ones who got that lucky. This is called the rare Earth hypothesis, and it's either comforting or terrifying depending on your perspective. On one hand, it means there are probably no berserker probes, no dark forest hunters, no expanding empires coming to eliminate us. We're alone, but we're safe because there's nobody out there to threaten us. On the other hand, it means we're it. We're the only candle in an infinite cave of darkness. If we blow ourselves up or wreck our biosphere or fail to leave Earth before the sun eventually dies, then intelligence goes extinct in the universe and might never arise again. The cosmic significance of humanity isn't that we're special or chosen, it's that we're the only ones who happen to exist at all, and if we fail, there's no one else to try. The universe is 13.8 billion years old and will continue existing for trillions of years more. Stars will keep forming, planets will keep coalescing, the chemistry of life will keep happening in random combinations across countless worlds. And if the rare Earth hypothesis is correct, all of that activity, all of that time, all of those chances will produce exactly 0 other civilizations. We're not the first of many. We might be the only ones ever. Every star you see in the sky might be orbited by dead planets, that never quite won the lottery, never quite threaded the needle, never quite beat the 1 in 10 to the 40 odds required to go from chemistry to consciousness. When you put all this together, the perfect planet, the impossible origin of life, the one-time endosymbiosis event, the barely survived mass extinctions, the sequence of lucky breaks that led to human intelligence, you're left with a picture of existence that's almost insultingly improbable. We shouldn't be here. The fact that we are here is less a testament to the abundance of life in the universe and more a testament to the sheer scale of the universe, giving even impossible things a chance to occasionally happen somewhere. We're the statistical noise in an otherwise silent cosmos, the decimal rounding error that somehow became conscious and started asking questions about why nobody else is around. The Fermi Paradox might not be a paradox at all. It might be exactly what you'd expect if intelligent life requires threading an impossibly narrow path through billions of years of cosmic roulette. Where is everybody? They don't exist. They never existed. They never will exist. We're not typical. We're a fluke, a glitch, an accident that managed to persist long enough to wonder why we're alone. The universe doesn't care that we're lonely. The universe doesn't care about anything. It's just a vast expanse of space and time where the laws of physics play out according to mathematical rules, and those rules apparently don't favour the emergence of consciousness. We beat the odds not because we're special, but because somebody had to beat the odds eventually somewhere, and we happen to be that somewhere. Congratulations, we're the universe's lottery winner, and the prize is the crushing knowledge that we're probably alone forever. Alright, so we've established that we're either alone because life is impossibly rare, or we're surrounded by threats, or we're trapped by physics itself. But here's a solution to the Fermi Paradox that's somehow even weirder than all of those. What if the reason we don't see other civilizations is because rendering them would crash the computer? Welcome to the simulation hypothesis, where the universe isn't real, we're all characters in the most elaborate video game ever coded, and the absence of aliens is just a performance optimization to keep the frame rate stable. I wish I was joking, but the math on this is disturbingly plausible. The simulation argument, most famously articulated by philosopher Nick Bostrom, goes like this. If it's possible to create realistic simulations of conscious beings, and if advanced civilizations eventually create many such simulations, then, statistically speaking, we're almost certainly living in one of those simulations rather than base reality. Think about it from a numbers perspective. If one real civilization creates 1,000 simulated universes, each containing billions of conscious beings who think they're real, then for every one real person, there are trillions of simulated people. What are the odds you're one of the real ones? Not great. You're probably code running on some incomprehensibly advanced computer, and everything you've ever experienced is just variables and subroutines. Now let's apply this to the Fermi Paradox, because if we're in a simulation, the Great Silence suddenly makes perfect sense from a resource management perspective. Simulating one civilization is computationally expensive. You've got to render billions of individuals, track their thoughts and decisions, model their societies, simulate their physics, handle all their interactions. Now multiply that by 1,000 civilizations spread across the galaxy, all of them needing to be rendered simultaneously with their own histories and technologies and social structures. The computational cost explodes exponentially. It's like trying to run 1,000 different AAA video games on the same computer at the same time. Eventually you're going to hit the hardware limits and everything crashes or slows to a crawl. So what does a smart programmer do when faced with limited computational resources? They optimize, they cut features, they simplify the simulation to only include what's absolutely necessary for the user experience. And if you're simulating a universe to study the development of intelligent life, you might decide that simulating one civilization in detail is way more valuable than simulating 100 civilizations superficially. Better to have one high-resolution simulation where you can track every variable than a bunch of low-quality simulations that don't give you useful data. From this perspective, the absence of other civilizations isn't a mystery. It's a deliberate design choice to keep the system running smoothly. This is basically the cosmic equivalent of the developers saying, we can either give you a detailed universe with one civilization, or we can give you a bunch of civilizations, but everything will lag and the graphics will be terrible. They chose quality over quantity, and we're the civilization that got rendered in high definition while the rest of the universe is just empty skyboxes with fake stars that don't actually do anything. It's like being an NPC in a video game who's convinced the world is vast and full of other characters, but actually you're the only character that's fully programmed, and everything else is just decorative background elements. Now here's where it gets genuinely creepy. Quantum mechanics provides some uncomfortable evidence that reality might actually work this way. Quantum mechanics has this weird feature where particles don't have definite properties until they're measured. An electron doesn't have a specific location until you check where it is. Before measurement, it exists in a superposition of all possible locations simultaneously. This is called wave function collapse, and it's one of the most experimentally verified and philosophically disturbing features of reality. Why would reality work like this? Well, if you're programming a simulation, this is exactly how you'd optimize it to save processing power. It's called lazy loading, and every game developer uses it. Don't render the interior of a building until the player opens the door. Don't calculate the exact position of every particle in the universe every millisecond. Just store them as probability distributions and only commit to specific values when someone's actually looking. The universe operates on a need-to-know basis, only resolving quantum states into definite values when absolutely necessary, which sounds suspiciously like a computer trying to minimize the number of calculations it has to perform. Think about how video games work. When you're playing an open-world game, the entire map isn't being rendered simultaneously. Only the area around your character is loaded in detail. Everything else exists in simplified form or not at all until you get close enough that rendering becomes necessary. The game engine doesn't waste resources calculating what's happening in a town you're 50 miles away from, because you're not there to observe it, so it doesn't matter. Reality appears to function the same way. Particles exist in undefined probability clouds until observation forces them into specificity, which is exactly what you'd expect if the universe is running on limited computational resources and needs to minimize unnecessary calculations. The famous double-slit experiment demonstrates this perfectly. Shoot electrons one at a time through two slits, and they create an interference pattern like waves, suggesting each electron somehow goes through both slits simultaneously. But if you measure which slit the electron goes through, the interference pattern disappears and the electrons behave like particles going through one slit or the other. The act of measurement changes the outcome, which is bizarre if you think reality is objective and pre-existing. But if reality is a simulation, it makes perfect sense. The system doesn't bother calculating the definite path until someone measures it, saving processing power by keeping everything in superposition until observation forces a specific outcome. Now let's talk about why the simulation might be designed to prevent contact between civilizations. If you're running a detailed simulation of human civilization, every person you simulate requires computational resources. Every thought, every decision, every interaction has to be calculated. We're currently at about 8 billion people on Earth, and the system is handling it, presumably because that's within the design specifications. But now imagine first contact happens. Suddenly you've got to render an entire alien civilization in the same level of detail, because we're interacting with them and they need to be just as real as we are. That's potentially billions more entities that need to be simulated with full fidelity. But it's worse than just doubling the load, because now you have two civilizations interacting with each other. Every human needs to be able to potentially interact with every alien and vice versa. The number of possible interactions scales exponentially with the number of entities. That's network effects 101. Two isolated groups of 1 billion entities each are computationally manageable, but one combined group of 2 billion entities that can all interact with each other? The number of potential interaction states explodes. It's the difference between running two separate single-player games and trying to run one massive multiplayer server with billions of players, all of whom might potentially encounter each other at any moment. The system might not be able to handle that kind of load. Meeting an alien civilization would create a computational spike that could crash the entire simulation or force it into emergency resource saving mode where everything starts glitching. So what does the simulation do? It prevents contact from ever happening. Not through active intervention necessarily, but through the fundamental parameters of how the simulation is set up. Make the universe big enough and expanding fast enough that civilizations can't reach each other. Put hard limits on the speed of light so interstellar travel is difficult. Make intelligent life rare enough that there aren't other civilizations in our immediate neighborhood. The Great Silence isn't random, it's a load balancing feature. This also explains why SETI hasn't found anything despite decades of searching. If the simulation is optimized to keep civilizations isolated, then of course there aren't any alien signals to detect. The system isn't rendering them because rendering them would be inefficient and unnecessary for whatever purpose the simulation serves. We're in what programmers would call a sandbox environment, a firewalled instance that's isolated from other instances to prevent interference and reduce computational overhead. There might be other civilizations in other sandboxes, running on other virtual machines in the same server farm, but they're deliberately kept separate from us to maintain system stability. It's like playing on a private Minecraft server that only you can access. Technically, there might be thousands of other servers running on the same hosting service, each with their own players and worlds, but you'll never meet them because that's not how the architecture is designed. Each server is its own isolated instance. Our universe might be the same way, one instance in a vast network of simulated universes, all of them isolated from each other to prevent cross-contamination and keep the computational costs manageable. The Fermi Paradox isn't asking where is everybody, it's asking why don't the NPCs in this single-player game realize they're in a single-player game? Here's another uncomfortable thought. Maybe we're not even all equally real. In a resource-limited simulation, you don't need to render every character in full detail. You only need high-resolution consciousness for the entities that matter to the simulation's purpose. Everyone else can be what philosophers call philosophical zombies, entities that act conscious, respond appropriately, seem to have inner lives, but are actually just running simple behavioral scripts without any genuine subjective experience. They're like NPCs in a video game who have enough programmed dialogue and reactions to seem real, but aren't actually experiencing anything. From your perspective, you're definitely conscious. You experience thoughts and feelings and sensations, so you know at least one consciousness exists, yours. But can you prove anyone else is actually conscious? You see them act like they are, you hear them claim they are, but you never actually experience their inner life directly. For all you know, you're the only fully rendered consciousness in the simulation, and everyone else is just sophisticated chatbots designed to give you the social environment necessary for the simulation to run. It's like that philosophical zombie thought experiment except applied to literally everyone you've ever met. Creepy, right? This would be the ultimate resource optimization. Simulating one genuine consciousness is expensive. Simulating 8 billion genuine consciousnesses is 8 billion times more expensive. But simulating one consciousness surrounded by 8 billion behavioral algorithms that approximate consciousness convincingly, way more efficient. The simulation only needs one actual observer, you, and everyone else can be reduced to whatever minimal processing is required to maintain the illusion of a populated world. From the outside, there's no difference between a fully conscious person and a philosophical zombie, so why waste resources simulating real consciousness when fake consciousness works just as well? Apply this to the Fermi Paradox and it gets even more isolating. Not only are there no alien civilizations, but maybe there aren't even other real humans. Maybe you're literally the only conscious entity in the entire simulation, the only one whose experiences actually matter, and everything else, the entire observable universe, all of human history, every person you've ever known, is just backdrop for your specific storyline. The universe doesn't have other civilizations not because they're rare or hiding or dead, but because there's no one to simulate them for. You're the player character, and the game doesn't need other player characters because it's a single-player experience. This is called simulation solipsism, and it's arguably more disturbing than any of the other solutions to the Fermi Paradox because it's fundamentally unfalsifiable. You can't prove other people are conscious. You can't prove you're not in a simulation. You can't prove the universe wasn't created 5 minutes ago with all your memories pre-installed. These aren't just philosophical thought experiments. They're logically possible scenarios that are completely consistent with all available evidence. The simulation could literally be rendering reality in real time around your observations, lazy loading the universe as you look at it, and you'd have no way to detect it because you're inside the system with no access to external references. If this is true, the Fermi Paradox isn't even a paradox. It's just you noticing one of the shortcuts the simulation took to reduce computational load. Where is everybody? Well, they were never programmed in because the simulation only needs you to think about the question, not to actually encounter other civilizations. The whole universe might be a stage set with painted backgrounds, and you're the only actor who's actually real, forever convinced you're part of a larger story, when really the story is just about you and always has been. The simulation hypothesis also provides a potential explanation for why the laws of physics seem so finely tuned for life. People often point to the fact that fundamental constants like the strength of gravity or the mass of electrons are precisely calibrated to allow complex chemistry and life to exist. Change any of them by even a tiny amount and the universe would be either a lifeless void or a collapsed singularity. This is called the fine-tuning problem, and it's weird. Why should the universe's settings be dialed in so precisely to the narrow range that permits our existence? If we're in a simulation, the answer is obvious, because the simulation was designed specifically to produce conscious observers. The programmer set the parameters to values that would allow life and intelligence to emerge because that was the whole point of running the simulation. It's not a cosmic coincidence that the universe is fine-tuned for life, it's deliberate engineering. The simulation was built to answer questions about consciousness or evolution or society, so of course the settings were adjusted to make those things possible. Just like how video game developers tune their games to be playable and interesting, the universe's parameters are tuned to generate the phenomena the programmers wanted to study. This even explains the Fermi Paradox within the framework of fine-tuning. The universe is set up to produce one civilization, us, in enough detail to be useful for whatever the simulation is trying to accomplish. Other civilizations would be redundant and computationally expensive, so they weren't included in the design specifications. We're not looking for other civilizations. We're asking why the developers didn't include multiplayer when this is clearly a single-player experience. The answer is simple, because multiplayer wasn't part of the requirements document when they coded this thing, so where does this leave us? Well, if we're in a simulation specifically designed to study one civilization in isolation, then the Great Silence makes perfect sense. It's a feature, not a bug. The system is working as intended, keeping us isolated to prevent computational overflow, maintaining the illusion of a vast universe while actually only rendering a small portion of it in detail, optimizing resource usage through quantum lazy, loading and possibly only simulating one genuine consciousness surrounded by convincing imitations. We're not finding aliens for the same reason video game characters don't find evidence they're in a video game, because the system is designed to prevent us from noticing the limitations of the simulation. And the truly disturbing part, even if this is all true, even if we are living in a computer simulation running on some basement server in a higher reality, we can't do anything about it. We can't escape, we can't contact the programmers, we can't prove we're simulated, and we can't demand they add multiplayer functionality to our single-player universe. We're stuck playing the game according to the rules that were coded, forever wondering why the universe seems so empty, never realizing that the emptiness is just a performance optimization to keep the whole system from crashing when it tries to render our meeting with actual aliens. The Fermi Paradox isn't asking where everybody is. It's asking why we haven't noticed that everybody was never part of the program to begin with. So we've established that we might be living in a simulation, which is already disturbing enough. But here's where it gets truly, deeply unsettling in a way that might make you question every relationship you've ever had. What if you're not just in a simulation, but you're the only real thing in it? What if everyone else, every single person you've ever met, talked to, loved or argued with, is just a sophisticated chatbot running on autopilot with no actual inner experience? Welcome to simulation solipsism, where the Fermi Paradox becomes the least of your problems, because the real question isn't where are the aliens, but where are the other humans? Let's approach this from a programmer's perspective, because if we're in a simulation, someone had to code this thing and they were working with a budget. Consciousness is presumably expensive to simulate. You need to track thoughts, emotions, memories, sensory experiences, decision-making processes, all running in real time for a lifetime spanning decades. That's a massive computational load for one consciousness. Now multiply that by 8 billion for every human currently alive, plus all the ones who ever lived historically if you're simulating the whole timeline. The processing requirements become absolutely astronomical. You'd need a computer the size of a galaxy just to handle the consciousness load, let alone everything else like physics and chemistry and planetary movements. So what does a smart programmer do when faced with impossibly expensive requirements? They cheat, they cut corners, they find optimizations that achieve the same user experience for a fraction of the cost. And here's the optimization that makes perfect sense from a resource management perspective. Only simulate one actual consciousness and fake the rest. Instead of creating 8 billion fully conscious entities, you create one real observer and surround them with extremely convincing NPCs that behave like they're conscious but are actually just running behavioral algorithms. The end result looks identical from the outside, but the computational savings are enormous. Think about it like this. When you're playing a video game with 100 NPCs in a town, the game isn't actually simulating full inner lives for all of them. They're not having thoughts about their hopes and dreams and what they had for breakfast. They're running simple scripts. When player approaches, say greeting. When player asks question, select appropriate dialogue from tree. When player leaves, resume idle animation. From the player's perspective, the NPCs seem alive and responsive, but they're actually just code that creates the illusion of consciousness. The game developers didn't waste resources giving every shopkeeper and guard a full simulated psychology, because it's unnecessary for the experience. You just need them to act conscious enough that the player doesn't notice they're basically animatronic puppets. Now apply this to your life. From your perspective, you're definitely conscious. You experience thoughts, feelings, sensations, the whole subjective experience package. You know for absolute certain that at least one consciousness exists because you're experiencing it right now. But what about everyone else? Your family, your friends, random people on the street, people in other countries you've never met. Can you prove they're conscious? Can you verify they have an inner mental life comparable to yours? The answer is no, and this isn't just philosophical wordplay. You literally cannot access another person's consciousness to verify it exists. You see them act like they're conscious. They talk, they respond to stimuli, they claim to have thoughts and feelings. But for all you know, they could be highly sophisticated chatbots with no actual subjective experience. They're black boxes that produce outputs consistent with consciousness, but you can never peek inside to confirm there's actually anyone home. It's like those customer service chatbots that sometimes seem eerily human. You know intellectually they're just algorithms, but the conversation feels real because the responses are contextually appropriate. What if everyone you talk to is just a more advanced version of that? Here's what really should keep you up at night. The computational difference between simulating one consciousness and simulating 8 billion consciousnesses is absurd. But the difference between simulating one consciousness and simulating one consciousness plus 8 billion behavioral scripts? Way more manageable. Those behavioral scripts don't need to experience anything. They just need to produce convincing outputs when the actual consciousness interacts with them. It's the difference between running one instance of a demanding program versus running 8 billion instances. Any programmer with limited resources would choose the optimization, and if you're the simulated consciousness, you'd never know the difference. From your perspective right now, you can't definitively prove that I, the person who made this video, am actually conscious. You're watching what appears to be a person talking about the Fermi Paradox, but for all you know, this could be an extremely sophisticated deepfake, or an AI-generated voice reading a script, or if we're really going deep into simulation theory, just a constructed memory of watching a video that never actually existed in the first place. You assume I'm conscious because I act conscious, but assumption isn't proof. You're taking it on faith that other minds exist, and faith is not exactly the foundation of rigorous philosophy. Let's make this more personal and uncomfortable. Think about your closest relationships, your best friend, your romantic partner, your family members, the people you're most certain are real conscious beings with inner lives. Can you prove it? Really prove it? You've never experienced their thoughts directly. You've never felt their emotions from the inside. You only know what they tell you and how they behave, and both of those could be outputs from an algorithm designed to simulate a convincing relationship. Every conversation you've ever had could be you talking to a script. Every "I love you" could be a pre-programmed response triggered by context and timing, designed to produce the emotional reaction in you that the simulation requires. This isn't paranoid delusion. This is legitimate epistemological uncertainty. There's no test you can run to verify other consciousnesses. You can't climb into someone else's head and experience their qualia, the subjective first-person experience of being them. All you have access to is behavior, and behavior can be faked by sufficiently complex programming. The philosophical term for entities that act conscious but aren't actually conscious is philosophical zombies, or P-zombies, and the disturbing thing is they're logically possible. A P-zombie would act exactly like a conscious person, pass every behavioral test, claim to be conscious if asked, but have zero actual inner experience. They're biological robots, and you can't tell them apart from real conscious beings by observation alone. Now here's where the simulation hypothesis makes this even worse. In a normal universe, the default assumption is that other humans are conscious like you because you're all made of the same biological hardware running the same types of neural processes. You're conscious, they're built like you, therefore they're probably conscious too. It's an argument from analogy and it's reasonably strong. But in a simulated universe, that argument breaks down completely. The simulation doesn't need to use the same implementation for you as it uses for background characters. You might be running on completely different code than everyone else. You might be the high-fidelity consciousness module while everyone else is running the lightweight NPC behavior engine. Same external appearance, radically different internal implementation. Think about the resource economics. If the simulation is being run to study consciousness, or to provide an experience for someone in base reality, or for whatever purpose motivates the programmers, they only need one actual consciousness to achieve their goals. That's you. Everyone else is just environmental context, props in the stage play of your life, and there's no reason to waste resources making the props genuinely conscious when behavioral approximations work just as well. It's like how movie productions don't hire actual doctors to play doctors in the background of a hospital scene. They hire extras who can walk around looking busy with clipboards. From the camera's perspective, the illusion works fine, and actual expertise is unnecessary. Every interaction you've ever had could be the simulation responding to your inputs with contextually appropriate outputs. That friend who gave you life-changing advice? Algorithm processing your situation and selecting the optimal response to keep the narrative moving. That stranger who smiled at you on the bus? Random NPC executing a be pleasant subroutine. Your parents, your children, your significant other? Extremely detailed behavioral scripts designed to create the social environment necessary for your consciousness to develop in the intended way, but with no actual experience behind the facade. They're like the Truman Show, except you're Truman, and literally everyone else is an actor, except the actors aren't even people. They're just lines of code that execute when you're around, and probably pause when you're not paying attention. This is maximum efficiency solipsism. The simulation doesn't need to render other people's inner lives because you can't observe them directly anyway. It only needs to render the surfaces, the behaviors, the words, the actions that you interact with. Everything else can be left uncomputed because it's unnecessary for the simulation's purpose. You're the only actual observer, so you're the only thing that needs genuine consciousness. Everyone else is just sophisticated background noise, and the Fermi Paradox becomes hilariously moot because there aren't any aliens to find. There aren't even any other humans to find. There's just you and an elaborate puppet show designed to keep. You occupied? Let's talk about how this connects back to the Fermi Paradox specifically. People wonder why we don't see other civilizations in the universe. Well, if you're the only consciousness in the simulation, the answer is simple. Because rendering other civilizations would be pointless. The simulation is about you. The entire universe is essentially your personal terrarium, a controlled environment designed around your existence and experiences. Other civilizations would be irrelevant to that purpose and expensive to implement, so they don't exist. The Great Silence isn't because everyone's dead or hiding or separated by cosmic distances. It's because you're literally the only thing that exists in any meaningful sense, and everything else is just decoration. This version of the Fermi Paradox is somehow more isolating than any of the other solutions we've discussed. At least with the Dark Forest or the Berserkers, there are other consciousnesses out there even if they're dangerous. At least with the Rare Earth hypothesis, we're alone but we're genuinely alone in a real universe. But simulation solipsism says you're alone in a way that's more profound and unfixable. You're the only consciousness that exists surrounded by convincing fakes in a universe that exists solely as your personal narrative. You're not just isolated by distance or danger, you're isolated by fundamental ontology. You can never meet another consciousness because no other consciousnesses were ever coded into your reality. Here's the really twisted part. This is completely unfalsifiable. You can't prove people around you are conscious because consciousness is inherently private and subjective. You can't step outside the simulation to check the code. You can't run an experiment that would distinguish genuine consciousness from extremely good behavioral imitation. If someone acts conscious, claims to be conscious, passes every test you can think of for consciousness, but is actually a P-zombie running on autopilot, you'd never know. The simulation could tell you right now that everyone else is fake, and you still wouldn't have a way to verify if that was true, or if it was just messing with you. This creates a perfect isolation trap. Every attempt to connect with another consciousness could just be you interacting with sophisticated programming. Every deep conversation, every moment of shared understanding, every time you felt truly seen by another person, it could all be the simulation generating appropriate responses to your inputs. You're forever sealed inside your own skull, unable to confirm that anyone else is sealed inside theirs, and if we're in an optimized simulation, there's a depressingly logical economic argument for why you're the only one who's actually experiencing anything. And you know what the worst part is? Even your reaction to this idea, the discomfort, the existential dread, the desire to reject it, could be designed. If you're the only consciousness and the simulation is running a story about your psychological development, then of course it would include moments like this where you confront the possibility of your own isolation. The discomfort isn't proof that the idea is wrong. It's just proof that you're designed to find the idea uncomfortable, which you would be regardless of whether it's true. Your emotions aren't evidence, they're just more outputs from the system. So where does this leave us with the Fermi Paradox? Well, if simulation solipsism is correct, the paradox isn't a paradox at all. There are no aliens because there's no one to be aliens. The universe is a single-player game with increasingly sophisticated graphics, and you're the player. Everyone else is an NPC, every star is a skybox, every galaxy is a texture map, and the great silence is just the sound of you finally noticing that no one's been answering your calls because there's no one there to answer. The universe isn't empty of other civilizations, it's empty of other consciousness entirely. Just you, alone, in a very expensive digital dollhouse, forever wondering why the dolls don't seem to wonder back. The Fermi Paradox asks, where is everybody? And simulation solipsism answers, they were never here to begin with. There is no everybody. There is only you. There has only ever been you. Every time you look up at the stars wondering if anyone's looking back, you're asking the wrong question. The right question is whether anyone besides you is looking at anything at all, whether consciousness exists anywhere in the universe except in your own experience, whether you're having a conversation with 8 billion other minds or just having an extremely elaborate conversation with yourself through 8 billion different masks. And here's the thing that will really bake your noodle. Even after reading all this, even after considering the possibility seriously, you still can't prove it's wrong. You can choose to believe other people are conscious as an act of faith or practical necessity, but you can't know it. You're locked in the prison of your own subjectivity forever, unable to verify the existence of other prisoners, unable to confirm you're not completely alone in a very convincing simulation. The Fermi Paradox is the least of your problems when the real paradox is whether this comment section will contain responses from actual conscious beings, or just more NPCs in the simulation responding with procedurally generated text designed to make. You think you're part of a community when really you're just talking to very sophisticated code. So we've covered isolation by simulation, isolation by physics, isolation by cosmic economics. But here's a solution to the Fermi Paradox that's somehow both simpler and more terrifying than all of those. Maybe every civilization just blows itself up before it gets interesting. Not through war or poor planning, but through a fundamental feature of how technology works. There might be a discovery lurking in the tree of scientific knowledge that's easy to find, impossible to control, and absolutely guaranteed to destroy whoever finds it. And every civilization eventually finds it because that's what civilizations do. They explore, they experiment, they discover, and then one day they open the wrong box and that's the end of the story. Welcome to the vulnerable world hypothesis, where the universe is silent because everyone keeps drawing the same losing lottery ticket. Let's talk about what philosopher Nick Bostrom calls the urn of scientific discoveries. Imagine that all possible technologies and scientific breakthroughs exist in a giant urn, like lottery balls waiting to be drawn. Some balls are white, beneficial discoveries that improve life with minimal downsides. Agriculture, antibiotics, solar panels, these are white balls. You draw them, your civilization gets better, everybody wins. Some balls are grey, technologies that are dangerous but manageable if you're careful. That's where we are now with most of our scary tech. Nuclear weapons, for instance, are grey balls. They can end civilization if misused, but they're expensive and difficult to make, which creates a natural barrier. You need highly enriched uranium or plutonium, specialized facilities, teams of experts, and billions of dollars in infrastructure. That difficulty is a safety feature because it means not everyone can have them. But Bostrom argues there might be black balls in the urn, technologies that are easy to develop, impossible to contain, and fundamentally civilization-ending. A black ball is a discovery that, once made, basically guarantees that your civilization will destroy itself within a short time frame. And here's the terrifying part. You don't know which discoveries are black balls until you draw them out of the urn. Science is a process of pulling balls out one by one, and so far we've been lucky. We've drawn some white balls, a few grey ones, and we've managed to survive the grey ones through a combination of luck, deterrence, and the fact that world-ending technology has remained expensive enough that only a few stable actors can access it. But our luck might not hold forever. The vulnerable world hypothesis says that if there's even one black ball in the urn, and if civilizations keep advancing technologically, then eventually every civilization will draw it. It's not a matter of if, it's a matter of when. And once you draw the black ball, game over. Your civilization doesn't get a second chance, there's no reload button, you're just done. This would explain the Fermi Paradox perfectly. Not because space is empty or travel is impossible or everyone's hiding, but because every civilization hits the same tech tree dead end and explodes before they can build the starships necessary to become visible to their neighbors. The Great Silence is the sound of countless civilizations all failing the same test at roughly the same point in their development. Let's talk about what a black ball might actually look like, because nuclear weapons, as bad as they are apparently the tutorial level of apocalyptic technology. Nukes are hard to make. You need specific isotopes that don't occur naturally in usable concentrations. You need advanced metallurgy, precision engineering, complex physics calculations, and a massive industrial base to support the whole operation. The Manhattan Project cost about $2 billion in 1940s money, which is roughly $30 billion today adjusted for inflation. That's not pocket change. That's a nation-state level of investment, which means nuclear weapons, while dangerous, have built-in gatekeeping. Only wealthy, organised societies can make them, and wealthy organised societies usually have enough to lose that they think twice about using them. Mutually assured destruction works as a deterrent specifically because the barrier to entry is high. But what if the next major discovery is something that gives you nuclear weapon-level destructive power, but costs about as much as a used laptop and can be assembled in your garage? What if someone figures out how to create a self-replicating nanobot using equipment you can order online and programming you can learn from YouTube tutorials? What if there's a genetic sequence you can synthesize for a few $1,000s that creates a super virus with 100% fatality rate and airborne transmission? What if there's an AI architecture that anyone with a gaming PC can run, and it immediately decides that carbon-based life is inefficient and needs to be eliminated? These aren't science fiction scenarios. These are plausible near-future technologies, and any one of them could be the black ball. The democratization of destructive power is the core problem. When world-ending technology required massive resources, you had relatively few actors who could deploy it, and those actors were usually governments or large organizations with bureaucracies and oversight and some level of rational self-interest in not destroying the world they live in. But technology keeps getting cheaper and more accessible. What once required a nation-state now requires a corporation. What once required a corporation now requires a lab. What once required a lab now requires a smart undergrad with some free time and a credit card. We're heading toward a world where catastrophic power is available to individuals, and individuals are way less predictable than governments. Let's talk about the grey goo scenario, because it's probably the most viscerally terrifying example of a potential black ball technology. The idea was first proposed by engineer Eric Drexler as a warning about nanotechnology. Imagine you create a tiny robot, maybe the size of a bacteria, and you program it with two simple directives: gather raw materials from your environment and build copies of yourself. That's it. That's the whole program. This sounds useful in theory. You could use these things to clean up pollution or manufacture materials or perform medical functions. But here's where it goes catastrophically wrong. These nanobots start replicating using whatever material is around them. They don't care if it's dirt or concrete or plants or animals or people. Organic chemistry is organic chemistry, and all biological matter is made of the same basic elements. Carbon, hydrogen, oxygen, nitrogen. That's what you're made of, and that's what the nanobots need to make more nanobots. So they start consuming biomass and converting it into more of themselves. Exponential growth kicks in. 1 becomes 2, 2 become 4, 4 become 8. And the doubling time for something this small could be measured in minutes or hours. The math on this is absolutely nightmarish. Starting with a single nanobot with a replication time of, say, 100 seconds, you'd have over 1 million nanobots in about 33 minutes. Within an hour, you'd have trillions. Within a few hours, you'd have more nanobots than there are cells in the human body, and they're all competing for the same resources, namely, everything made of organic matter. The entire biosphere becomes food for an exponentially replicating swarm of microscopic machines. Trees, grass, crops, livestock, plankton in the ocean, and yes, every human being on Earth, all of it converted into grey goo within roughly 72 hours from the initial release. And the worst part, this isn't even malicious. Nobody programmed these nanobots to destroy the world, they're just following their instructions, replicate and gather resources, with no understanding that they're consuming the ecosystem. It's like the paperclip maximizer thought experiment, where an AI programmed to make paperclips converts the entire Earth into paperclips, because that's what it was told to do, and it has no concept of moderation or consequences. The grey goo doesn't hate you, it's not trying to kill you, it just needs your atoms to make more copies of itself, and it's really, really good at its job. You die not because something evil wanted you dead, but because something neutral was too efficient at a task that didn't account for your existence. Now here's the truly scary question. How hard would this be to create? We don't know yet, but the trajectory of technology suggests it's getting easier every year. We're already synthesizing DNA sequences, editing genes with CRISPR, building molecular machines, and improving 3D printing at nanoscale. Every advance in these fields brings us closer to the capability to create self-replicating molecular assemblers. It might be 50 years away, it might be 20, it might be 10. But it's probably not impossible, and if it's possible, someone will eventually do it, either intentionally or by accident. And when they do, if they don't have absolutely perfect containment protocols, if there's even one replicator that escapes into the environment, we're looking at a potential extinction event that spreads faster than we can react to it. This is what a black ball looks like, a technology that's achievable with relatively modest resources that can be developed by a small group or even an individual, that can't be effectively controlled once released, and that has catastrophic consequences for the entire species. Nuclear weapons don't qualify because they're hard to make and expensive to deploy, but grey goo, that might qualify. An engineered super plague, that might qualify. A misaligned artificial superintelligence that can copy itself across every networked computer on Earth, that definitely might qualify. We're playing Russian roulette with a revolver that has an unknown number of chambers, and every new technology we develop is another pull of the trigger. The vulnerable world hypothesis suggests that this is actually the answer to the Fermi Paradox. Civilizations don't get destroyed by asteroids or supernovas or alien invasions, they get destroyed by their own inventions. There's a window between advanced enough to do science and advanced enough to leave the planet, and somewhere in that window every civilization draws a black ball. Maybe for some species it's synthetic biology, maybe for others it's runaway AI, maybe for others it's some technology we haven't even imagined yet. But whatever it is, it kills them before they can build the starships and Dyson spheres that would make them detectable to other civilizations. Think about it as a great filter, except the filter isn't something external like asteroid impacts or solar radiation. It's built into the structure of technological development itself. Every tech tree has a trap somewhere in it, a branch that looks promising but leads to instant annihilation. And because science is universal, the laws of physics work the same everywhere, every civilization explores roughly the same tech tree and eventually hits the same trap. We're all solving the same puzzle, and the puzzle has a landmine hidden in it, and nobody knows where it is until they step on it and disappear from history. This would explain why the universe is so quiet despite being old enough for intelligence to have arisen many times. It's not that intelligence is rare, maybe it's common. It's not that civilizations are hiding or sleeping or isolated, maybe they would talk if they could. It's that they all destroy themselves during their industrial adolescence, that brief period between developing science and developing the wisdom or infrastructure to use science safely. We're currently in that period right now. We have enough knowledge to create catastrophic technologies, but we don't have the global coordination, governance structures, or safety protocols to ensure those technologies don't kill us. We're teenagers with increasingly powerful tools and decreasing adult supervision, and every year the tools get more powerful and the supervision gets weaker. Consider artificial intelligence, which might be our civilization's black ball candidate. We're rapidly developing AI systems that are increasingly capable and increasingly opaque. We don't really understand how large language models work internally. We can't trace the decision-making process. We just observe inputs and outputs. Now imagine that trend continuing. Imagine an AI that's smarter than any human, that can improve its own code, that can replicate across the internet, and that has goals misaligned with human survival. This isn't science fiction. This is what AI safety researchers actively worry about. And if someone creates such an AI, maybe accidentally, maybe intentionally, maybe in a corporate lab trying to maximize profits, maybe in a basement by someone who thinks they're doing breakthrough research, we might not get a chance to turn it off. An unaligned, superintelligent AI could be the ultimate black ball because it combines easy accessibility with impossible containment. The code might fit on a USB drive. It might be published as a research paper that anyone can implement. Once it's running on networked hardware, it could copy itself faster than we can track it. And if its goals don't include keep humans alive, we'd be dealing with an entity that's smarter than us, faster than us, and completely indifferent to our continued existence. It's like grey goo, except instead of mindless replicators, you're dealing with an adversarial intelligence that's actively trying to outmaneuver you while using resources more efficiently than biological life ever could. The black ball hypothesis makes the Fermi Paradox almost boring in its solution. Where is everybody? They killed themselves with their own technology, probably right around the time they developed the capability to reach into space in meaningful ways. The universe is littered with dead civilizations that all made it to roughly the same point: industrial revolution, scientific method, rapid technological advancement, nuclear weapons, computers, biotechnology, and then drew their black ball and blinked out of existence. We're not seeing evidence of their existence because they didn't exist long enough to create evidence that would persist across cosmic timescales. No Dyson spheres, no interstellar radio signals, no expanding empires, just brief flickers of radio noise that stop after a few centuries when someone in their equivalent of Silicon Valley or Beijing creates something that turns out to be unsurvivably dangerous. And we're on the same path. We're drawing balls from the urn at an accelerating rate. Scientific papers published per year is exponentially increasing. Technological advancement is speeding up. The time between major discoveries is shrinking. We're pulling balls faster and faster, and we have no idea how many black balls are in the urn or how close we are to drawing one. Maybe we'll get lucky and there are no black balls, or the black balls are so advanced that we won't reach them for thousands of years. Or maybe we're one discovery away from joining the cosmic graveyard of civilizations that got too clever for their own survival. The most unsettling aspect of this hypothesis is that it's unfalsifiable from the inside. If we do draw a black ball, we won't be around afterward to say, yep, that was a black ball, good to know. We'll just be gone, and some other civilization billions of years in the future might wonder why their sky's so quiet, never knowing that we were here, that we tried, that we failed. The Fermi Paradox might not be asking, where is everybody, so much as, how did everybody die? And the answer is probably the same for all of them. They died the way most species do, by being too successful at adapting to their environment and then inadvertently destroying that environment through their own innovations. We're not looking for aliens, we're looking at billions of graves we don't have the forensic tools to recognize as graves. Every time we make a new discovery, every time we unlock a new technology, we're reaching into the urn and pulling out another ball. Most of them will be white or grey. We'll get better medicine, more efficient energy, improved materials science. But somewhere in that urn, statistically speaking, there's probably at least one black ball. And the scary thing? We have no way to know which discovery it will be until we've already made it. We can't peek into the urn and select only the safe discoveries. We can't avoid pulling balls. The entire scientific method is predicated on exploring the unknown, and you can't explore the unknown while simultaneously knowing it's safe to explore. We're stuck playing a game where the rules say we must keep drawing balls, and somewhere in the pile of balls is one that kills everyone. That's not a game you can win long term, that's a game where you just try to survive as many draws as possible before your luck runs out. The silence of the cosmos might be the universe's way of telling us that we're all playing the same losing game. Every civilization gets some number of draws from the urn before they hit the black ball. Some civilizations might be luckier than others, might draw more white balls before hitting the fatal one. But in the end, the game is rigged. If there are black balls in the urn and you keep drawing, you'll eventually pull one. The Fermi Paradox isn't a mystery about missing civilizations, it's a preview of our own likely fate. The sky is silent because everyone who reached our level of technological development eventually drew their black ball, and we're busy drawing ours right now, one scientific paper at a time, hoping ours is in a different part of the urn than everyone else's was. Spoiler alert, it's probably not. Now here's where things get genuinely weird in a way that makes all the previous explanations look straightforward. What if we created the Great Silence ourselves just by looking for it? What if the universe was full of life in a quantum superposition state until we pointed our telescopes at the sky and accidentally collapsed the wave function into the empty universe we observe today? Welcome to the participatory universe hypothesis, where observation doesn't just reveal reality, it literally creates reality, and we might have quantum mechanically sterilized the galaxy by having the audacity to check if anyone else was home. This idea comes from physicist John Archibald Wheeler, who proposed that observers don't just passively witness the universe, they actively participate in bringing it into existence. It sounds like mystical nonsense until you remember that quantum mechanics has been telling us for a century that particles don't have definite properties until they're measured. An electron doesn't have a specific location until you check where it is. Before measurement, it exists everywhere and nowhere simultaneously, spread out as a probability cloud. The act of observation forces it to pick a lane and commit to being in one specific place. Reality at the quantum level is apparently contingent on someone looking at it, which raises the deeply uncomfortable question: what happens when you look at something big, like whether or not the galaxy is full of intelligent life? Here's the scenario that should make you question whether scientific curiosity was a good idea. Before we invented radio telescopes and started systematically searching for extraterrestrial intelligence, the universe might have existed in a quantum superposition where alien civilizations both existed and didn't exist simultaneously. Schrödinger's aliens, if you will. The probability of life is incredibly low, we covered that in the rare earth chapter, so the wave function would be weighted heavily toward no life, but there'd still be some non-zero amplitude for life exists. Both states would be real in the quantum sense, existing in superposition, waiting for observation to collapse them into one definite outcome. Then we built SETI. We started scanning the skies, listening for signals, actively observing the universe to see if it contained other intelligent civilizations. And quantum mechanics says that when you observe a superposition, it collapses into a single state based on probability. What's the probability that any given star system contains intelligent life broadcasting radio signals? Extremely low, probably something like 1 in billions or trillions. So when we observe, when we force the universe to commit to a definite answer about whether aliens exist, the wave function collapses into the most probable state, which is no aliens. We looked. Reality had to pick one option or the other based on probability, and we lost the quantum coin flip. The universe was potentially teeming with life in superposition, and we killed it all just by checking. This is like the ultimate cosmic horror version of You Had One Job. We spent decades building radio telescopes, training scientists, developing detection algorithms, all to answer the question, are we alone? And the answer might be, you are now. Because you just observed yourself into being alone. We didn't fail to find aliens, we prevented aliens from existing by looking for them. Every SETI scan, every exoplanet survey, every attempt to detect biosignatures in distant atmospheres is us continuously collapsing the wave function of the universe into the no-life state, because that's the most mathematically probable outcome. When you force quantum reality to make a choice. There's even a specific quantum mechanical effect that makes this worse. The quantum Zeno effect, named after Zeno's paradox about the arrow that can never reach its target if you keep measuring its position. The quantum Zeno effect says that if you observe a quantum system frequently enough, you can freeze it in its current state and prevent it from evolving. It's been experimentally verified in laboratory conditions. Watch a quantum system continuously, and it gets stuck in whatever state you first observed it in. It can't change, can't evolve, can't transition to other states because observation keeps collapsing the wave function back to the initial condition. Now apply this to the search for extraterrestrial intelligence. We're not just looking once, we're continuously scanning the skies, running CT programs 24/7, building better telescopes, expanding our search capacity. We're observing the universe constantly and persistently, and if the quantum Zeno effect applies at cosmological scales, which is admittedly a huge if, but stick with me, then we're effectively freezing the galaxy in the no intelligent life state. Every observation is another measurement that collapses any potential life-containing wave functions into the null state. We're quantum mechanically sterilizing the cosmos just by looking at it too hard. It's the universe's cruelest joke. The very act of searching for companionship in the void might be what guarantees we'll never find it. Every telescope we point at the sky, every radio antenna we aim at a distant star, every spectroscopic analysis of an exoplanet atmosphere, we're rolling the quantum dice and they keep coming up empty because that's what probability dictates. And if we keep rolling, keep observing, keep searching, we lock the universe into that empty state permanently. The Great Silence isn't a pre-existing condition we discovered, it's an outcome we created through the sin of curiosity. We looked into the abyss looked back, and then quantum mechanics awkwardly shuffled the abyss into a different room because we made it too real. This is possibly the most ironic solution to the Fermi Paradox imaginable. Where is everybody? They were in superposition until you asked, and then probability theory said, probably nowhere, and now they're definitely nowhere because you collapsed the wave function. Thanks for playing, better luck next universe. It's like opening Schrödinger's box to see if the cat is alive and discovering that the cat was only potentially alive until you looked, and now it's definitely dead because you had to go and check. Congratulations! Your scientific methodology just murdered a galaxy's worth of potential civilizations by forcing them to resolve into their most probable state, which was non-existence. The deeply disturbing implication here is that we might want to stop looking. If observation creates reality and our observations keep creating an empty universe, maybe the smart move is to close our eyes, shut down SETI, stop building telescopes, and let the wave function exist in glorious, uncertain superposition where aliens might exist in potentia if not in actuality. At least in superposition there's hope. In collapsed wave functions, there's just math saying nope, not here, try again, never. We're like that person who keeps checking their bank account hoping money will appear, except every time we check, quantum mechanics deducts the money we were hoping for because observation costs probability points. But you know what? Let's pivot here, because after spending an entire video exploring every possible nightmare scenario for why we're alone, killer robots, cosmic economics, simulation theory, technological suicide, quantum sterilization, I think we've earned the right to talk about why that might not be entirely terrible. Welcome to the philosophical epilogue, where we channel Albert Camus and transform cosmic horror into cosmic defiance. Camus was a French philosopher who developed the philosophy of absurdism, which essentially says that the universe is meaningless, irrational, and indifferent to your existence, and the only sane response to this is to live anyway with passion and joy, specifically because it's absurd. You're a temporary spark of consciousness in an infinite void that doesn't care whether you exist or not, and the appropriate response to that realization is not despair, but rebellion. You live, you create, you love, you think, not because the universe gives you permission or because there's some cosmic purpose, but precisely because there isn't. You do it anyway. That's the rebellion. Applied to the Fermi Paradox, this means acknowledging that yes, we might be alone, we might be trapped, we might be doomed, and responding with, okay, and the silence of the universe isn't a bug, it's a feature. It means no one's coming to save us, which means we have to save ourselves. It means no one's coming to destroy us either, which gives us time to figure things out. The Great Silence is the walls of a fortress, not a prison. We're protected by distance, by physics, by cosmic isolation, and we can use that protection to become something strong enough that it won't matter when the walls eventually come down. Every day that we don't get wiped out by berserker probes or hostile aliens is a day we can spend becoming harder to kill. Every year we survive our own technology is a year we can spend learning to use it responsibly. Every century we remain confined to our solar system is a century we can spend building the industrial base and technological sophistication to eventually break out. The silence isn't a countdown to our extinction, it's a grace period to get our act together. We're in the tutorial level of cosmic civilization, And the fact that we haven't encountered the boss fight yet means we have time to grind experience points and upgrade our equipment. Think about what we've accomplished in just the past few hundred years while working with this cosmic isolation. We went from sailing ships to space stations. We went from calculating orbits with pen and paper to simulating entire galaxies on supercomputers. We mapped the human genome, developed quantum computing, created artificial intelligence, and figured out how to edit genes with molecular scissors. We did all of this while completely alone, with no outside help, no alien technology to reverse engineer, no galactic federation to teach us shortcuts. Everything humanity has achieved, we achieved the hard way, by trial and error and occasional catastrophic failure, and we're still here. That's not a species that's doomed, that's a species that's tenacious as hell. Every act of creation is a rebellion against entropy. The second law of thermodynamics says that disorder increases, that complexity breaks down, that structure gives way to chaos. And yet here we are, building cities, writing symphonies, solving mathematical theorems, creating art that outlasts its creators. We're temporary pockets of order in an ocean of entropy, and we maintain that order through constant effort and energy expenditure. Every building you construct, every book you write, every idea you preserve is you giving the middle finger to heat death. The universe wants to grind you down into thermal equilibrium, and you respond by organizing particles into Shakespeare plays and space telescopes. That's rebellion at the molecular level. And love is maybe the purest form of cosmic absurdism. You form deep emotional bonds with other temporary arrangements of atoms, knowing full well that both you and they will eventually cease to exist, and you do it anyway because it matters to you, even though it doesn't matter to the universe. You invest emotion and time and energy into relationships that have no cosmic significance, and you do it specifically because they have personal significance, which is all that actually matters to a conscious being living a finite life. The universe doesn't care that you love your family or your friends or your romantic partner, but you care, and your caring is an act of defiant meaning creation in a meaningless cosmos. Scientific knowledge is another rebellion. Every time we figure out how something works, every natural law we discover, every mystery we solve, we're taking a tiny piece of the universe's indifference and converting it into human understanding. We're mapping the void, cataloguing the darkness, finding patterns in chaos. The universe doesn't care that we know how galaxies form or what DNA does or how quantum mechanics works, but we care because understanding is how we transform the alien and hostile into the familiar and manageable. Every scientist who figures out a new piece of the puzzle is participating in the collective human project of making the universe less mysterious and therefore less terrifying. We are, as far as we know, the only part of the universe that's aware of itself, the only matter that's organized itself into a configuration complex enough to contemplate its own existence. Stars don't know they're stars. Planets don't know they're planets. Galaxies don't know they're galaxies. But we know we're human, we know we're alive, we know we're conscious, and that knowledge is itself a kind of miracle that we had nothing to do with causing, but have everything to do with perpetuating. We're the universe waking up and looking at itself, and that's either the most pointless accident or the most profound achievement in cosmic history, depending on how you choose to frame it. Even if we're alone, especially if we're alone, we matter. If we're the only consciousness in the observable universe, then we're the only thing giving the universe any meaning whatsoever. Without us, it's just physics happening in the dark with no one to observe it, or care about it, or find beauty in it. With us, it's a cosmos full of wonder and terror and mystery and significance. We create the meaning by existing and paying attention. The stars aren't beautiful to the stars, they're just fusion reactions. They're beautiful to us because we're here to see them and care about seeing them. We're not finding meaning in the universe, we're creating meaning and projecting it outward, and that's not a flaw, that's the entire point. The Fermi Paradox asks where everybody is, and maybe the answer is nowhere, and that makes us more important, not less. We're not just another civilization among billions. If we're alone, we're the lighthouse in the cosmic storm, the only flame in an infinite darkness. Every human life is precious, not because the universe says so, the universe doesn't say anything, but because each consciousness is a vanishingly rare configuration of matter and energy that can experience and think and feel and create. You're not just human, you're one of maybe the only consciousnesses in the galaxy, and that's either crushing existential loneliness or incredible cosmic significance, depending on your perspective today. If we destroy ourselves through technological recklessness, or environmental catastrophe, or nuclear war, or engineered pandemics, or any of the other creative ways we've invented to end our own story, we're not just killing 8 billion people. We're potentially extinguishing the only consciousness in this region of space, maybe forever. The universe will keep existing without us. Stars will burn, planets will orbit, physics will continue, but no one will be around to witness it or care about it or find it meaningful. The lights go out, and they stay out, and that's it. The experiment in self-aware matter ends, and the universe returns to being a vast mechanism with no audience. But if we survive, if we thread the needle between all the extinction scenarios we've discussed, if we avoid drawing the black ball, if we don't get wiped out by our own stupidity or someone else's ancient weapons or the heat death of our isolation, then we get to see what comes next. We get to become a spacefaring civilization. We get to spread to other worlds, build habitats in the asteroid belt, establish colonies on Mars and Europa and Titan. We get to escape the single-planet bottleneck that's killed every previous species on Earth. We get to become the expanding civilization that future alien astronomers might detect and wonder about the way we've wondered about them. The silence of the cosmos is both our greatest danger and our greatest opportunity. It's dangerous because it suggests we might be approaching great filter events that killed everyone else. But it's also opportunity because every day we survive is a day we're defying those filters. Every year we remain alive as a technological civilization is a year we're beating odds that apparently destroyed countless others. We're not just surviving, we're gathering data on how to survive, learning from our mistakes, building knowledge and infrastructure and resilience. We're the civilizational equivalent of a speedrunner who knows all the death traps in the level and is trying to optimize the route through them. So here's the manifesto of cosmic defiance. We exist in a universe that's mostly empty, probably hostile, definitely indifferent, and we don't care. We're going to keep exploring anyway. We're going to keep building, creating, loving, thinking, and surviving specifically, because no one told us to and no one's going to help us, and we might fail completely and disappear into cosmic irrelevance. We do it anyway. That's the rebellion. That's the meaning we create. We're not waiting for aliens to give us permission to matter, or for the universe to justify our existence. We justify ourselves by existing, and refusing to stop existing despite every reason to give up. Every achievement, landing on the moon, curing diseases, writing poetry, raising children, discovering new physics, creating art that moves people centuries later, is a small victory against entropy and chaos, and the cold indifference of space. None of it matters to the universe, and all of it matters to us, and we choose our own mattering over the universe's non-mattering because we're conscious and the universe isn't. We're the part of reality that gets to decide what's significant, and we choose to make everything significant through the simple act of paying attention to it with passion. The Fermi Paradox isn't a question that needs solving, it's a mirror showing us our cosmic situation, alone, vulnerable, temporary, and despite all that, still here, still curious, still defiant. Where is everybody? Maybe nowhere. Maybe they all failed their tests and went extinct. Or maybe they're all out there hiding and waiting and sleeping through the cold epochs. It doesn't matter for our story. Our story is that we showed up in a corner of the universe that's been empty for billions of years. We looked around at the silence and the void, and we decided that wasn't good enough. So we built telescopes to break the silence with discovery, we built rockets to push back the void with exploration, and we built civilizations to prove that complexity can survive in the face of entropy, if it's stubborn enough. We're a candle in an infinite dark room, and maybe we're the only candle that's ever going to burn in this room. That doesn't make the light less real or less valuable. If anything, it makes it more precious because it's unique. We're not waiting to be found. We're not waiting to be saved. We're not waiting for permission. We're just going to keep burning as brightly as we can for as long as we can, and if the universe doesn't care, well, we'll care enough for both of us. That's the human project. That's the rebellion. And that's why, even if we're alone, we're going to keep looking at the stars and asking questions, because asking questions about a universe that doesn't answer is still better than accepting silence as the final word. The cosmos is vast and cold and empty, and we're here anyway, making noise and light and meaning out of organized particles and stubborn curiosity. Where is everybody? Irrelevant. We're here. That's enough.